Hello everyone, in this video I'm going to show you how we can obtain a potential function for a conservative vector field in our tree in less than 2 minutes. Believe me, it's going to be less than 2 minutes. So let me first remind you about the notion of a potential function for a vector field, and then I will briefly explain what is the more standard way to obtain a potential function for a vector field in some reference books. And then finally, I will explain about a shortcut that helps you to obtain a potential function for a vector field in less than 2 minutes. So, okay, let's cut to the chase. So, suppose that we have a vector field in our tree. So, therefore, our vector field has 3 components. So this component called the I component of our vector field, this component is called the J component of our vector field, and this component is called the K component of our vector field. We also assume that our vector field also is continuous, and also the partial derivatives of m, n, and p are continuous, right? So if the vector field f is conservative, then f is equal to the gradient of f for some function f from R3 to R, right? And what this means, it means that m, n, and p is equal to f sub x, f sub y, f sub z. And what this means that f sub x is equal to m, f sub y is equal to n, and f sub z is equal to p, right? And now based on these equations, we should obtain f of x, y, z, right? The usual method is that you can start with one of these equations, for example the first one. So f sub x is equal to m, then take an integral with respect to x. Therefore here you have f of x, y, and z is going to be integral of m dx. And here you have an integration constant, but this constant is going to be a function based on y and z. And now the problem boils down to somehow to evaluate or to obtain this function c of y and z, right? And then you can go ahead and also take an integral with you already have this f, then take an integral with respect to y, and then compare it with n, and then so on, that you might know about this method. So I don't want to spend too much time to explain this method. So here is our trick. So you can obtain a potential function basically by evaluating 3 integrals, namely these integrals, plus dy plus integral dz. Now what we should put here in these places? Okay, here in this place we put all the terms of the I component of f, right? Just put all the component of I component of our vector field. This is going to be m, for example, in this case. Now, and here all the terms of the Now the J component that do not contain x, right? Contain x. And here put all the terms of K component that do not contain x or y. So let me explain this method more by doing some examples, right? Okay, here is the first example. So you can easily check that this vector field is conservative, therefore it has a potential function. So now the potential function can be obtained by this. Okay, this is going to be integral dx plus integral dy plus integral dz. Now put the all terms of the I component here, e to the x cosine y plus yz, and then here just ignore all the terms of the j component which contain x. Therefore, you should ignore this, and you should also ignore this. Therefore, here there is nothing to put, right? How about the next one, the k component? Here, I should ignore all the terms of the k component which contain x or y. Therefore, I should ignore this part, and I only have y, right? I only have z. Therefore, this is going to be the integral with respect to x is e to the x cosine y plus yzx. This is going to be 0, and therefore this is going to be z squared over 2 plus c, right? So let's do another example. Here, this is another conservative vector field. You can check that out. And f of x and y and z is going to be integral dx plus integral dy plus integral dz, right? Okay, put the all terms of the I component here, x squared plus yz plus e to the y. Now, here, just ignore all the terms which contain x. Okay, ignore this. Then what we have is this term and this term. Therefore, I have here y cubed plus z squared. How about the last one? The last one is just ignore all the terms which contain x or y, right? Therefore, I should ignore this and I should ignore this, right? Therefore, I only have e to the z. Now take an integral. Therefore, here you have x cubed over 3 plus yzx plus x e to the y. And now this integral is going to be y to the 4th over 4 plus yz squared. And then the last one is going to be e to the z plus a constant, right? But this is somehow a true constant, right? So let's do the last example. So here again is a conservative vector field in R3. So you can check that the curl of this vector field is going to be 0. Therefore, this is going to be conservative. Therefore, you have a potential function f sub x, y, z. Okay, this is going to be integral dx plus integral dy plus integral dz, right? Okay, put the I component here, right? Then now just ignore all the terms which contain x, therefore just ignore this. Therefore here you have z e to the yz plus y, and here ignore and now here just ignore all the elements with y, with x or y. So therefore you should ignore this, you should ignore this. Therefore what you have is z e to the z squared. Therefore you can go ahead and compute. But here for this integral of z e to the yz dy, so here let's just compute it. So here is going to be let me write down here 3x plus y squared plus 2xz. Here is going to be 3 over 2 x squared plus plus x y squared plus x squared z. This is for the first one. How about for this? For this this is gonna be e to the this is gonna be e to the yz, right? Plus y squared over 2, right? And the last one is gonna be 1/2 e to the z squared plus a true constant, right? And this is now gonna be your potential function. So if you find this video interesting, please subscribe my channel and also like this video. Thank you very much.